All right, so today we're going to talk about the exponent rules, and there's a few of them that you just have to memorize them when you see them and what you're supposed to do. So like we've already discussed before, we've discussed the adding and subtracting of monomials. And so really all you have to do there is just combine like terms. And just remember, you're not changing the common variables in the exponent. So you're really only dealing with the coefficients, which are the numbers in the front. So if we look at example 1, we have 9x squared y minus 10x squared y. Now we know that these are like terms because they both have the same variables x and y, and both of the x's still have the exponent of 2, and the y's have an exponent of 1 even though it's not written. So now we're just going to worry about the coefficients and do 9 minus 10, which is negative 1, or we can just say negative x squared y. Okay, so that's just us adding and subtracting the monomials. For the second example, you want to subtract 8w from 6w from 8w. So remember we talked about we want to subtract 6w from 8w. We're going to start with 8w and then subtract 6w from it. And remember we got like variables with the same exponent, so we can just deal with the coefficients. So 8 minus 6 is 2, and we keep the w. Okay, so we just did practice with that. All right, so now let's talk about the product rule. And so here's the rule. If you have x to the a times x to the b, we're going to keep the x, and then we're going to add the exponents. So a plus b. And we're going to multiply the coefficients. So in this case, the coefficients in front of here are 1. So 1 times 1 is 1, and that's why we didn't write it. But whatever the coefficients are, we multiply those, and then we keep the variable, and we add the exponents. So in example 1, we have h to the second power times h to the sixth power. So the coefficients are 1, so we have the 1h, and then the exponents are 2 and 6, so we're going to add those, and we end up with h to the 8th. In example 2, our problems actually have coefficients other than 1. So the coefficients will be negative 2 and 7. So we're going to multiply those like normal. We get negative 14. But now we're going to deal with the variables. So we have an a to the second and an a to the third. So we're only going to worry about those first. So we'll have a, and then we're going to add the exponent. So 2 plus 3 gives us 5. And then we're going to deal with the b. And even though there's no exponent written, it's understood that these exponents are 1. So then when we're using the product rule and these are being multiplied, you're really going to add the exponent and you end up with 2. So our answer will be negative 14, a to the 5th, b to the second power. All right, so now we have the power rule when you have a power, so x to the 8th, raised to another power to the b power. And so what you do here is you keep the same variable, but then you multiply these two exponents. So it'll be a times b. So in this example 1, x to the second power raised to the third power would be x, keep the same variable, and then we'll do 2 times 3, which is 6. Because really this means, we know cubed is something 3 times. So x squared, which is x times x, and this means I need to have it 3 times. So x times x times x times x times x. So we end up with 6 x's, so this is x to the 6th power. All right, so if we look at example 2, we actually have multiple rules going on. So we're going to have the power rule, and then we're going to have to end up using the product rule at the end. But so we're only going to use the power rule with this here. And if there's a coefficient other than 1, you actually have to raise this coefficient to the second power. So remember, negative 2 to the second power. And remember, if you put that in the calculator, the negative 2 must go in parentheses. So negative 2 to the second power is 4. And then we're going to do m to the 5th to the second power. So in that case, remember that you need to multiply. So you get m to the 10th. And then we're going to do times m to the 3rd. And so we're not done. And one way to know we're not done is if your final answer has the variable in more than one spot, you haven't simplified as far as you can go. So now we're going to multiply. So 4 times this one has a coefficient of 1. So that's 4. And then m to the 10th times m to the 3rd. Remember, with our product rule, we add these exponents. So we get 4m to the 13th power. And this is our answer here. Okay? So that's the power rule. And now we have our quotient rule. So hopefully you know quotient means division. So when you start seeing them look like division, what we do is if they're coefficients, you simplify them. And in this case, it's just 1. And so then you keep the the variable, and then you subtract the exponents. So this would be a minus b. So in this case, in example 1, we're going to look at 27 over 42, which are the coefficients for each one. And so we're going to simplify those, and you can simplify those by 3. And so you get 9 over 14. And then we have x to the 5th over x. So remember, this x has an exponent of 1 here. So now we're going to subtract them, x to the 5th over x to the 1st. And then we get x to the 4th. And make sure every time you subtract them, you put the answer at the top. And so now this is our final answer. Everything is as simplified as it can go. So let's look at example 2. So now we're going to have to combine multiple rules. So here, I hope you see that we have a power rule going on. So this becomes y to the 4th, because remember the power rule, you have to multiply the exponents here, over y to the 4th. Okay, and so then using the quotient rule, we would subtract these. And so we get y to the 0 power, which is at the top, over 1. And then y to the 0 power is equal to 1. And we're going to talk about that here in a second. Okay. But hopefully you can just see y over the 4 over y over the 4th power. They cancel each other out. So then here you're left with 1. So since we're on this subject, let's talk about the 0 power rule. And I know this is not in your chart, but find some place to write this down. So anything to the 0 power is 1. Y to the 0 power is 1. 1,000 to the 0 power is 1. Okay, so here we have negative 3, but then we have the x to the 0 power, which is 1, so times 1, so this really simplifies to negative 3. So over here, you're probably like, well, where's the 0 power? Well, let's use our quotient rule. We got 3 over 12, which can simplify to 1/4. And then we do c to the 3rd over c to the 3rd. So we're going to subtract them. And we get c to the 0 power. And so now hopefully you see that c to the 0 power is 1. So 1 times 1 is really 1/4. Okay. And now let's talk about the negative exponent rule. So when you have a negative exponent, all that means is it's in the wrong spot. So if it's at the top, you need to move it to the bottom. And if the negative exponent is at the bottom, you need to move it to the top. So here we have x to the negative a. And so really what that means is x to the a, make it positive. But now we had to move it downstairs, because really this is over 1. And so we just had to move it downstairs to make it positive. And then if there's nothing left in a spot in the numerator of the fraction, you just put a 1. All right, and then so let's look at some examples. So we have negative 5x to the negative 2 power. So the negative 2 power is connected to the x, so that is the one we have to move. The negative 5 does not have a negative exponent. It's just a negative 5. The coefficient is negative 5. So that's going to stay where it is at the top. And we're going to take this and move it downstairs to make it positive. So we get x to the second. So now we have negative 5 over x to the second. As you can see, I didn't move the negative 5 from the top. It stayed in the top. Only the x to the negative second had to go down to the denominator to be x squared. So if we look at example 2, hopefully you see there's no negative exponents yet, but here's the quotient rule. So 4 over 8 would simplify to 1 over 2. And then so then we do k to the second over k to the fifth, which is the quotient rule, so we're going to subtract. 2 minus 5 is to the negative third. So this will be k to the negative third. Now you're never done if you still have negative numbers in your problem. So we still got to simplify. So now the 1 stays, but the k to the negative third has to move downstairs with the 2. So it'll be 2 over k to the third. And remember, when you move it, it becomes positive. Now the 2 didn't have to go anywhere, and it just stayed put. So now this is your final answer. Okay, and so these are all of your exponent rules.